got a lot of animals in your metaphors. It seems like you grew up on a farm or something.
Yeah,
Raining cats and dogs and sheep eating wolves. 5, 6, 7, 8. Welcome to Proglangcast episode 10. This episode is going to be about the Scheme programming language, and I'm going to be presenting implementations of bye-bye hello world in Scheme. My name is Christopher Augustus.
I'm Steve Thames.
Since our last recording, we now have the audio podcast. A lot of new things have happened since then. We interviewed Bob Terrio, and then we were interviewed on the Arraycast. We have cross-pollinated or cross-podcastinated with the Arraycast. They've actually mentioned us quite a few times, and we mentioned them. And so far, we've interviewed Adam Brudevsky and then Bob Terrio. And hopefully we're going to try to get others from the Arraycast, Stephen Taylor, Marshall Lochbaum, Connor Hoekstra. That'd be fun, wouldn't it? To get everybody from the Arraycast.
especially Marshall.
It's interesting you bring up Marshall because Connor Hoekstra has already started yet another podcast.
Yes.
Tacit Talk. Did you know about this?
No, you just can't keep that boy down, can you?
And he started it as a live cast on YouTube for the first time. I was there in the chat channel and asked a few questions, but his first interview was with Kai Schmidt, the creator of Weewa, and his next episode is Marshall. That's why I brought that up.
Oh, cool.
The creator of BQN, the creator of Singeli. If you go to Code Report channel on YouTube, then it comes out on audio later. So it's actually out there as audio. It's called Tacit Talk. Your favorite subject of all, Steve. Completely tacit programming.
Right. So I'm very interested in it, but I don't have the background in it. So
well, you're going to get a background soon, maybe. Yeah. I've already started to pull array code into proglangcast, our website. We're creating this information base about programming languages and all the details with the ability to do comparisons across different aspects of those languages. So one, we need a large model, and it feels to me multidimensional. It's at least a table, which is a rank 2 array, a matrix, at least.
What is the language that's most used for algorithms that count sheep? Okay, so we've got one for counting sheep, and you click on it and it shifts the screen. And as you drill down into the model, we say of the ones that are counting sheep, how many of them are creating a progression of how many sheep are killed by wolves in the wintertime. You know, on any of these points that you would drill down further and further into the model, and then it would narrow down. Show me how many times the moon has been full in February when it's been raining like cats and dogs.
I think you're right about what we're expecting the site to do, but in terms of sheep and wolves, you're quite more imaginative about it than I am. I was thinking more like, show me all the languages that have mutability as a default. So you got a lot of animals in your metaphors. It seems like you grew up on a farm or something.
Yeah,
Raining cats and dogs and sheep eating wolves.
Did you want to talk about Scheme at all?
Let's dive into Scheme. This is kind of the hierarchy of Lisp and all of its descendant languages. And you can see Scheme is in there. Lisp stands for list processing.
Okay.
But a lot of people who don't like Lisp will probably tell you that Lisp stands for lost in stupid parentheses or lots of superfluous parentheses. And what I'm looking at, and again, for our audio-only listeners, this is a graphic of a kind. There are two paragraphs. It says what I see at the top, and at the bottom is a paragraph that says what the non-Lisper sees. And at the top, it's what I see, and the words are in bold black font, so they stand out. And the parentheses are a diminished gray, so the parentheses don't really stand out. I see mostly the words.
Oh, okay. All right.
Right.
I'm
Define,
following you.
Carry, if not nil, let, cond, recurse, right? Just reading it like you would read a programming language.
Okay.
In the paragraph below, it says what the non-Lisper sees. And in this case, all the words are in a dimmed gray, so we can barely see them. But what's in black bold are all the parentheses. And there's a big blob of text that says, oh God, pointing to all the parentheses. This picture could also be phrased differently. It could say, what I saw when I first came to Lisp, which is the bottom, what I see now that I've been doing it for a while.
Yeah, because that's what I'm seeing right now. I'm seeing the bottom when I look at Lisp.
I've been programming for a few years now in Scheme, and yeah, I see more of the top.
Something I find interesting about his example here, saying that the Lisper doesn't really see the parentheses so much. I would challenge that argument, because anybody who doesn't see them enough is going to run into a lot of difficulty when they're trying to make their programs work.
I'm actually going to agree with that last statement. I'm always aware of the parentheses. They're actually foremost in my mind, but they don't bother me. And in fact,
Right.
when I first came to Scheme, I found it attractive for one reason, and that was anytime I look at Lisp source, I know immediately that I'm looking at programming source. It looks different than a paragraph of words, pseudocode, or anything else. I immediately go, I'm looking at Lisp code. There's just no mistaking it whatsoever. Parentheses in Lisps are fundamental. One of the standout points of Scheme is it has less syntax than most other programming languages. So Scheme is in the Lisp family, and here's the timeline. This is on Wikipedia of Lisp. Obviously, you can see the family is large. It's got a long history. It was originally created in 1958. We can see the timeline going all the way up to 2020 here. You can see really people stopped using the original Lisp pretty early on, right? It doesn't really live past 1965 here. Its first offspring looks to be MacLisp, then InterLisp, then MDL. So Scheme shows up in 1975, and then it continues on from 1975. It goes through some standardizations, and it's very much thriving today. It's not mainstream, but there are production systems in Scheme. There's a large variety of implementations. It's definitely a solidly viable programming language. It's not esoteric. And then you can see some of the following Lisps. There's a lot. I think that there are primarily flavors of Lisp out there in use. Scheme is one. The next one, which we could debate about which one is used most, is called Common Lisp. And there are some distinct differences between Scheme and Common Lisp, and it has quite a lot of use. It's particularly strong in the realm of interactive programming. It has one of the best interactive environments. So Emacs has its own Lisp within it as its scripting language. Emacs Lisp, sometimes just referred to as eLisp. I don't know if it gets much use outside of the Emacs editor itself, but there's so many people using the editor. It definitely has a high presence in the field of computer programming.
So you're talking about a domain-specific Lisp.
This is a true Lisp. Emacs, of course, is produced by GNU, by the Free Software Foundation. Originally, Richard Stallman, one of the big implementations of Scheme called Guile, which also comes from GNU. And some people actually try to use Emacs with Guile instead of the Emacs Lisp. To your point about Emacs Lisp being an embedded scripting language, we do see a lot of variations on Scheme that are designed to be very small footprint, very lightweight, but robust scripting languages. And the fourth, I would say, is Clojure, a variation on Lisp created by Rich Hickey that runs on the JVM. It's been gaining ground over time. And in fact, a lot of people in the functional programming community, Clojure is kind of a standout in that community. There's a Clojure script that has almost identical syntax to Clojure that transpiles to JavaScript, and it's used in the front end, and then Clojure is used on the back end. The fifth most popular or most used or present variation of Lisp, I'm going to say, is Racke. Now, Racke is based on Scheme, and originally you can see it was called PLT Scheme. It's kind of become its own thing, and I have already written an implementation of Bye Bye Hello World in Racke, but I want to save covering that in a separate proglangcast episode, because Racke has one feature that's quite unique from all the other Lisps. These are all languages in the Lisp family, but Scheme is different from Common Lisp. Common Lisp is different from Emacs Lisp, and Racke is different from those. And Clojure is definitely different. Back to Scheme. So here we are, 1975. Scheme created by Guy Steele and Gerald J. Sussman. So here's Guy Steele. Go back to the list, we can see it's gone through a standardization process with this kind of strange initialism. It's the revision, the number, and the report on Scheme. And in fact, if we look at the actual site, revised 7 report on the algorithmic language Scheme. The latest standard is R7RS small. Prior to that is R6RS, and prior to that is R5RS. The Rs before that are really not present in today's schemes. There is one very large domain in which it historically has had a massive presence. But these days, that's diminishing, and that is in computer science courses in universities. This book right here is kind of known amongst those people who studied computer science in college. You and I, neither of us did. I studied physics in college. We grew up living and breathing programming. But apparently this book, Structure and Interpretation of Computer Programs, also known as SICP, quite a famous book. And you can see the name down here, Gerald J. Sussman, one of the authors of Scheme. Now free online, we actually go to the contents and we take a look at it. Everything's written in Scheme. It's meant to teach programming using Scheme as the language. It goes all the way to the end of the book to teach you how to write an interpreter for Scheme in Scheme.
Maybe I'll sit down and read through it, because I've actually never read this book before.
I actually started reading it a little bit, and Connor Huckstra has a series of videos on his Code Report channel in which he goes through all the chapters of this book. If we go back in time, back to the 50s and 60s, when programming emerged on the scene as a thing to do, there were kind of two schools of thinking. One is what they call the von Neumann machine. There's a famous mathematician, computer guy, von Neumann. His approach to programming is very much the way processors work, imperative. Move data here to there, do this, do that, do that. And that has become the dominant way of thinking about programming in general that has been infused throughout almost all of the languages that are in use today. But there is another side, and that side is the side of lambda calculus. That's where this sign comes from, this lambda sign. And these are the original lambda papers by Guy Steele and Gerald Sussman when they created Scheme. And you can see right there, he says, an interpreter for extended lambda calculus, which comes from a man named Alonzo Church. Lambda calculus itself is the simplest approach to programming. It's even simpler than the Turing machine and the von Neumann model. Everything that a program does, ultimately, even if it's interfacing devices, is going from one value to a new value, and it's a transformation of values to values. Lambda calculus is so simple. By defining a layer of functions, we can do everything. A set of functions that boil down to other functions that boil down to other functions that boil down to other functions. Even things like numbers themselves, like the number 1 and the number 2 and the number 3, believe it or not, can be expressed in terms of the most rudimentary lambda calculus. If you come from a mathematical background, it feels very natural. Remember that thing, the same problem with array languages. People who don't come from an imperative programming or don't come from a programming at all can jump on APL and jump on array languages quickly because they're not going through this filter of having thought about programming in a different way. It is their first exposure to programming.
I have not got a great deal of experience in array languages, but I do understand the concept of transformation of numbers from one value to another based on some kind of calculus, some kind of formula, or whatever you want to call it. So it's natural for me to come to this, but you could say it simpler by just saying people who couldn't grasp the idea of something beyond basic arithmetic calculations would have more trouble going into lambda-based programming.
We're going to have to dedicate some more time in proglangcast to the whole concept of lambda calculus and functional programming. It's too much to bite off here. And what's really sad, just like for the array languages, the By My Hello World is not going to demonstrate the essence. It's not a good test case for the strengths of data transformation because it's just this interactive I/O thing, right? It's like, give me a value and I'm going to push stuff out at you. So let's move ahead. The standardization process doesn't change very often, and you can see not a lot of work has been done in over 10 years now.
Well, maybe that's because it's complete. It's as good as it can get.
That's possible. If we go to scheme.org, I don't know who has this domain name. It's not like Scheme is standard amongst many implementations. Let's go to the implementations. There's actually more than are on this list. And each of these are implemented across many platforms. These implementations vary in the language itself. And you can see on the right-hand side, see the little R's? Notice that?
Right.
bbhw, R5. Chez, R6. Chibi, R7. Chicken, 5 and 7. Cyclone, 7. Gambit, 5 and 7. We get down to racke, you can see racke is still here considered a scheme, R5, R6, and R7. And there are differences in those standards. So not all schemes are the same.
How different is cyclone from gambit or gerbil from kawa?
Well,
Are these domain specific?
They're solution specific. So for example, bbhw is one of the few that actually compiles to JVM bytecode. Chez scheme is one of the biggies. It's also one of the fastest. And gambit is quite big out there. Chicken, I think, has pretty good presence. And then guile is the GNU one. This is online documentation for the scheme programming language posted by the people that make chez scheme. Originally built by Cisco, not open source for quite a while, and then it was open sourced. Idris is a completely different language in the ML family. Off of Haskell, and the creator of Idris decided to use chez scheme to implement it. So it's used as a tool for building compilers. Chez scheme decided, we're stopping at R6. We don't support R7. There's some controversy about the viability of R6 versus R7. And as you can see, there are other schemes here that have gone ahead to support R7.
Got it.
Chibi scheme. This is one specifically designed to be a very small, lightweight, embeddable scheme. There are two others of significance like this. S7, which is one of the implementations you're going to see. One that comes before Chibi scheme called Tiny scheme that I don't think is really supported to this day. Gambit is pretty big. So it actually generates C source, and then you compile the C. So it has very good bindings with C. And in fact, it says right here, approach the compatibility and performance of C. So the four implementations we're going to see are going to be chez, chibi, gambit, and S7. And I would have done bbhw, but again, I was struggling with getting the build from source, having a bunch of issues with that. Same thing with chicken. Chicken is one of the bigger schemes that's in use. Again, I was having trouble building that. Cyclone is one I don't know. Gerbil is one that is actually implemented in terms of gambit. So you have to have gambit to run gerbil, and I was having some trouble building this. Gauche, I don't know anything about. Guile is the GNU one. There's a distribution of Linux. They call it Geeks. I prefer to call it Gix, G-U-I-X. I don't know if you've heard about it.
I have no experience in it, but I have heard of it, yes.
You've heard of Gix. Gix is GNU's answer to Nix. And instead of having this unique language called Nix, they use Guile as the scheme. But there's a lot of issues with building this from source. There are others out there. Again, we could go through a lot of that, but that's what we have. Shall we look at source code?
So this is chez scheme. Let's do it.
What can you figure out just by looking at this?
Okay, give me a minute. This is my first time seeing it.
Never written Lisp code before?
Never written Lisp code before, no.
But you've seen it, glanced at it maybe.
I've glanced at it.
Okay.
I mean, I'm familiar with the structure of it,
Okay.
and I have never seen chez scheme.
Just give me a general impression, just looking at it. What do you get looking at the code and the syntax? And I mean, there's some highlighting there that's a little helpful, but in general, does it seem to be readable? Can you follow? I mean, yeah, you don't know what certain specific functions are, but you kind of get a sense of what's going on here.
I'm seeing some interesting statements here, like current input port and flush output port. That seems very straightforward and descriptive of what it's doing.
The syntax, right? We're talking about parentheses. Is this weird? When you look at it, do you just go like, "Oh, what is with all these parentheses?"
No, the parentheses don't bother me as long as they're uniform. Like I've got one open one or two open ones. I got to have one or two closed.
Do they look uniform to your eye?
Yes. Yeah.
Also notice that in this syntax highlighting, again, our audio listeners can't see it, but the parentheses are not diminished. They're a bright white.
Yeah.
The same color as the variable names. So we've got a variable name in there, count. We've got input, because it's bye bye hello world for those of you who've been following us. I could have picked a highlighting theme that diminished, darkened and had a faded gray. But I didn't want to do that here because I wanted to make sure that, if you're not using syntax highlighting to help you not be annoyed by the parentheses, that, they would stand out as much as anything.
Well, and I would say, in answer to your question, no, I do not find them annoying. I would find them annoying if I couldn't see them as well.
Ah, okay. So you'd prefer them not to be diminished.
Absolutely. Gotcha. I want to, for the exact same reason, if I'm typing the code And I'm like, okay, I got
Yeah.
parentheses. How many do I need? 1, 2, 3. Okay, I want to be able to clearly see how many I need.
Okay. What did you said just a little while ago? You were going to have an open mind, or you weren't going to be bothered by new languages. But when we did J, the first thing you said was, "It looks painful."
Mm-hmm.
Does this look painful?
No.
Notice there aren't very many symbols here.
No.
I mean, the predominant symbol is the parens, right? The open parentheses, the closed parentheses. But what other symbols do we have?
Mm-hmm.
I see a hash mark.
Right.
You're saying this hash F. By the way, in Scheme, I don't know other Lisps, it's just a constant. That's the constant for false. So false is hash F.
Oh, okay.
True is hash T. So they do actually have Booleans, unlike the.
Now this is dynamically typed, right?
It is dynamically typed. What else do I see in there? I see a question mark. I see double quotes. Yeah, those are pretty common symbols, right? Strings. Strings are enclosed in double quotes. What else do we see in there? There's an exclamation point, a bang. There's a less than.
Oh, right. That was what I was going to ask you about.
There's a dash for minus, but
for minus, yeah.
Really, I would say there are no semicolons. There are no braces. I don't see any brackets, any square brackets. So most languages, I would say, definitely have all three of the boundary symbols. So round parentheses, square brackets, and curly braces, right?
This one only appears to have the parentheses.
It seems to only have parentheses, at least in this code that you're looking at here. So the point I'm trying to make here is one of the claims to fame about Scheme, not all Lisps, Scheme in particular, is it has a minimal syntax. Mm-hmm. There are English keywords in here, like you made the point of cadr, or what's called cadr. But you see things you can recognize, like display, format. Mm-hmm. There's a sleep in there. There's a different color for other words. In other languages, they would be called reserved words or keywords, right? They call them special forms. There aren't very many special forms in Scheme. There's very few. And the ones we can see here are define, do, if, begin, set. That's it. Those are the only special forms in here. All the purple words in there are either functions in some library, in this case, a standard library. Now, obviously, when you're getting familiar with the language, you need to know more than just the symbols and the special forms or reserved words. You're also going to have some familiarity with its standard library. There is a weird symbol for the comment. Did you notice that?
3 semicolons?
Well, any number of semicolons. They decided to use semicolon as the comment character.
Okay.
It's kind of odd that they used the semicolon, because the semicolon shows up in so many languages we're familiar with as statement terminators.
I can do an inline comment that way, anything after the end of it.
That's exactly right. Not required by the language, but standard practice in terms of when you use 3 or 2 or whatever for documentation purposes. Like you can see in this case, the top of the file is the copyright, and then it's the Mozilla public license. And we use 3 semicolons at the beginning of the line, just as a standard, like this is a large document block header thing.
Sure.
So then the first line starts left paren or open paren, the word define, space, the word count, space, hash F, and then close paren. That's the first line. So what do you think that does?
Well, that's exactly, so that was the reason for me asking about the dynamic typing. Yeah. Because what you said in that statement is you're defining the variable count and assigning it the Boolean value of false. Right. But count as used as your counter later on down in the code. So that appears to make it clear that that could be a numeric value as well. Doesn't have to be Boolean. It's defined at the top as having a Boolean value, but it can be redefined later as simply having a number value.
You're exactly right. That demonstrates the fact that changes type. Let me bring up the shell. We still see the source mostly at the top. We've got the shell. So here we are in the directory. We're in our clone of the repo, bbhw code scheme. Now, because there are multiple schemes, you can see I was trying to do guile and I was trying to do gauche in Cyclone, but I didn't get very far with that, so we just have these. So right now we're in the chez directory. We just have the run file. Do the usual. We can see the run. You know, this is the whole thing where it'll download and build it automatically. What's funny is the default when you install chez, by the way, the default is not to be chez, the default is to be scheme. So they kind of grab the name scheme. You can see there's the version, and this is built from source. But I'm going to go ahead and exit this. Oh, it's funny. I put the period in there. So used to Erlang. You don't need a period for scheme.
But
so
you
anyway,
do need the parentheses.
You do need the parentheses, and I'm going to explain that in a
Quick
second.
question. It says here the copyright is 84 to 23 Cisco systems. So is it still belong to Cisco?
Well, it's open source, but they are the authors of it, so therefore they have the copyright.
I'm noticing in the run script, you're doing chez and passing in the script bbhw.ss. So, but then you're taking the parameters passed to the run script as $@, which takes all the parameters, but putting them in double quotes.
Don't even get me started on shell and bash, POSIX shell, dealing with quoting inside quoting and not quoting and all that. That's painful to me. That's a painful thing to deal with. So we're trying to make all our bbhws really simple. They always have a shell script .run. I type in /run, enter. It prompts me countdown, : waiting for input. I'm going to type in 3, as in 3 seconds. It says world, comma, hello, ... 3, ... 2, ... 1, ... bye bye, period. And it took a second to show me each second as it counted down. So that's bye bye hello world for those who haven't seen it or heard about it. Instead of simply printing hello world, we print world, comma, hello. Then whatever countdown you entered, it's going to count a second. It's going to print each second counting down from, in this case, 3, 2, 1. When it gets to the end, it's going to then complete the printout on the same line with by space by period, and that's it. I'll press run again. This time I'll give it a command line parameter, but I'm going to put in something wrong like frog. So I'm going to say dot. I mean, it's funny. I catch myself. I'm going to say. We're not saying anything. I typed into the prompt ./run space frog, enter. It prints out to me invalid countdown, frog in quotes, comma, try again, ... And then it prompts me for the countdown as it would have if I had not entered a command line argument. Let's try dog. Doesn't like that. Should I try -1?
Yes, that was the next thing I was going to ask for.
Countdown, : I'm entering -1. Oh.
It's coming up in quotes though, too.
But it is coming up in quotes. Okay, let's try a fraction, 0.5. Doesn't like 0.5. Let's try a stranded array, 1, 2, 3. Doesn't like that.
Oh, that comes in as one parameter. Okay.
I learned a little bit from our previous bye bye hello worlds and tried to make sure that we caught some of these cases of. Can I do what I did in J or APL? Can I put in an expression that evaluates to a number like 1 + 2? No. So it really wants an integer number. Right. What if I give it a really big one? I'll probably have to cut it off. I just entered a ton of digits.
Yes.
And it's counting down. Oh my God, how many digits did I enter? It's not quite a Googleplex, but it is counting down. Okay, so we've run the program. We've shown how it works. Let's go back to the code. Notice the editor, by the way, for those who can't see. It does help me if I put the cursor on a paren. Either a left paren, it'll show me the right paren that matches it. If I put it on the right paren, it'll show me the paren that matches it. And this is just Vim. Even the simplest editors will do that. This very first line is essentially the structure of any scheme expression, and they all have the same structure. The expression begins with the left paren, it ends with the right paren that matches it. And the only reason you would have parens inside those parens is if you have a sub-expression within that expression. This is lambda calculus, or one way to express lambda calculus. This expression has defined as what they call a special form. Now, the syntax here does not say I have to use a special form. I could actually make my own word. Define it. Count. What do you think? What do you think that would do?
I'm assuming it wouldn't do anything. I mean, you're saying that you don't have to use the define reserve word to define something? Is that what you're telling me?
No. What I'm saying is to make an expression, I don't have to use a special form. That is a name of a function to call. Let's make it not called define it. Let's call I don't know. Give me a word. Let's call it yellow. The rules here simply say you've given me a left paren. The next word that I see following that paren, if it's not needs to be a function that I can invoke. And the only choices available are functions that are somehow in the environment that either I've defined or in a library or something that's imported, or a reserved form, or special form. So define is a special form. The difference is that define, it's special. It's pre-made, it's built in, it's not a function. These parentheses form a data structure. All code is data in Scheme. Everything you're looking at in parentheses is a list. That's why it's list processing. It's a list structure that's defined by the parentheses. In this case, this list is used as an expression, but it's still a list. It has 3 elements in that list. So the head of the list is the word define. The second item in the list is the word count. And the third item in the list is the pound F. Right? If we look at any of these other parentheses expressions out there, you can see there's variable numbers of entries, but they are all lists. So first thing was we define count as false. Next line is left paren, define, space, input. Now we have another left paren. So we're now introducing a sub-expression within this expression. The list where the define is, it still has 3 elements. It's just now the third element, instead of being a single literal value like the pound F, is now an entire other list. So you can see it's lists within lists within lists within lists. In this case, expressions within expressions within expressions within expressions.
When you say list processing, in this case, what we're talking about is being interpreted left to right. Whereas if we were stack-based, we would be interpreting right to left. In other words, we would put pound F and then count on the stack and then call define. Well, and that was one of the questions I was going to ask about earlier.
Yeah, so it is left to right within the expression, but as soon as you introduce sub-expressions, it's inside out.
Well, then it comes down to precedence. The open parenthesis is an indication of a recursion. From the point of view of the compiler or the interpreter, it's now going to say, okay, we're going to recurse down and we're going to start processing this expression. And then we're going to say, oh, wait, we got another parenthesis, so we're going to go down and process this expression. Oh, we got another one, so we're going to process that expression. Now we've got the closing one. Okay, we process this, pop back up, and now execute the append.
It's like Russian dolls, right? You're at the outermost doll where it says left paren define. And then we go inside, we open up the doll, and we find, oh, there's another little doll inside. So before I can apply that outermost doll, I've got to keep evaluating in until I find the one that doesn't have any more dolls in it. And then I start applying back outward. So that's why I think of it as inside out versus in other languages that are more pipeline oriented like F#, where you've got the piping operator, it actually applies the first expression at the first pipe. Whatever that thing is, I'm going to call that function, I'm going to get a result. Now I'm going to take that result and pass it to the next thing. So it's much more sequential or much more top to down or left to right. Here, we have to parse the expression from left to right, but we don't perform anything until we get down to the smallest piece. And then we go in reverse order and apply each. So you can see define is a keyword that I'm going to apply, but not yet. Then I go to cadr and like, okay, that's a call to another function. I'm going to apply that, but not yet. I have to go into where there's a call to append, but I'm going to apply that, but not yet. I've got to get down to, command line now has no sub-expression within it. The evaluation is finished because there's no arguments there. It's a niladic operation. Now the interpreter will get the command line and then it will pop the result where that expression is, right? So now it's going to go to the next piece of the append. Oh, I've got another sub-expression. It's not a value yet. And that sub-expression is list. And list is a function that says, I want you to make a list out of these arguments. So it's now going to execute that. There's no more Russian dolls inside that one. Now we got to take these values and step back out to our outer Russian doll and apply those arguments to that call. and then that result gets applied, and that result gets applied. So this is one of the things that does bother me about Lisps and schemes. You do have to drill down to the last set of internal parentheses and then walk your way back to see how things execute.
Except that for me, I don't have any issue with that because it goes back to what I remember, of course, from learning first-year algebra.
Yeah.
Always processing the parentheses first.
Yes.
And that's something we carry along to all of our languages. Scheme doesn't have the chaining style that is common with some other languages, like F sharp you mentioned.
The pipe, no, it doesn't.
The pipeline type of, and also
no, it's inside out. It's what
Elixir.
I call it.
Elixir has that.
All right, so I'm going to read the line back. It says define input left paren cadr, also known as cadr. Then we've got a space, a left paren again, append, a space, another left paren again. Finally, we're at one of the innermost dolls, which is just the word command-line. This is a function in the standard library. By the way, this one is unique to chez. So command line is not part of one of the R7 standards. You're going to see when we go to the other sources, we won't see command line.
I'm assuming it's coming in as a list of strings.
And you would only know that by looking at the library and seeing what is the return value of that function. We get the command line. Then the next argument to append is left paren, list, space, double quote, close paren. This is going to take the literal string, empty string. It's not a list. So there are fundamental types in here that are not lists. Numbers are not lists. Booleans are not lists. Characters are not lists. Even strings, remember in APL and J, strings were arrays?
Yeah.
That's not the case here. A string is not a list.
In Erlang, a string is a list.
The lists in Scheme are unlike lists in most other languages, and they're made up of pairs. In an array language, you can make a string can be an array of characters, and it's very efficient. If you were to make strings lists, it would be very inefficient. Strings are not lists; they're sequences of characters. They're byte sequences or UTF-8 Unicode.
So they've created
sequences.
A type for that. So, but what did you mean when you said lists are pairs?
They're connections of pairs.
If I said list quote Steve quote space quote Chris quote, what would it give me?
So the first element is a pair, which is the empty string. The second element of the pair is a new pair that now has the first element of that pair is Steve. The second element of that pair is a new pair, and the first element of that is Chris, and the second element is nil.
They're all linked together.
They're actually one's inside the other. I mean, in memory, they could be referenced by pointers, but that's more of an implementation detail. Make them as values inside of values inside of values. I mean, semantically, that's how you think of them. Not one points to another, but one contains the other. It's a containment relationship.
And that's going to be important later.
It's important because if you'll notice, it's the same exact model of Russian dolls as is the expression, which is why the code itself is made up of exactly these same list structures. Everything is a list until you get down to primitives like Boolean, number, string. Let me show you what it actually looks like. It actually looks like this.
Ah, okay, I'm following you now.
Every one of these dots is a separator of a pair of values.
So is going to end up being in memory as a left paren, empty string, period, left paren, quote, Steve, quote, period, left paren, quote, Chris, quote, period, nil, right paren, right paren, right paren.
There's an elegance to it, but it's a confounding one that, as you can think about coming from just standard imperative programming, you could see why people go at this and go, I don't want to touch this.
Well, maybe that'll make it easier to understand. You've got the command line and you've appended a single list, a single element list of an empty string to command line.
I know that the command line is always going to have at one entry, which is the name of the program that got invoked. But the problem is I don't want that one element. I only want the second element. But if there's no second element and I reach for a second element, I'm going to get an error. In this case, because it comes back as a list, I'm using the result of command line as an argument to append because I want to append another list to this list. I know after this append, I have a list of at least 2 items, right?
Input is either going to be the command line argument or the empty string.
It's never going to be the first argument of the command line, which is the name of the script or whatever, right?
Right.
What the hell is this cadr? All right. So there are a bunch of built-in functions in Scheme. So this is not a special form. That's why you can see it's in purple. It's a function.
Yep.
This
Car.
car, CAR says, whatever list, give me the first element of that list.
So CADR says the second element?
CDR says, give me the second element of the list.
Whoa, wait a minute.
Guess what
Okay.
CAR and CDR are, where they got the names from? Machine register instructions. Something,
You're kidding.
you know, it looks like assembly language, right? It's like move,
Yeah.
shill, sure.
Oh, yeah.
SH.
The CAR says take the first element of the array.
Yes.
CDR says take the second element.
Yeah, and the second element of a list, if it contains more lists, is the rest of the list.
So
That's
the
the-
CADR is saying, give me the first element of the second list.
So
In other words,
yeah, so you can do this. You can do CDDR. You can do CADDR. You can do
Oh my.
CAADDR. There's a whole bunch of these you can do. It's a convenience. So CADR says,
okay, I'm gonna use a phrase that you enjoy coming from me. That's painful.
I knew you'd like this
At
part.
least I could see how somebody's going to think of that as painful, right?
Well,
I'm gonna go
because
CADD. How many A's do I have there? How many D's do I have
no,
there?
but it is a
What's my
nice
list
shorthand
size?
because the alternative is doing this.
Yeah.
CAR of CDR, and I've got to do an extra parentheses.
Mm-hmm.
By doing CADR, it's just a convenient way of doing that.
Right. And if I was teaching this language, that's how I'd tell them to do it. I'd say, write it out exactly how you want
CAR,
it.
CDR,
And then pull those other letters, get rid of the other R's,
Yeah.
all the R's.
The cars, the cadrs, the cadrs, the cars.
Yeah.
But
All right.
it's
actually pretty cool.
It is kind of cool. These things are immutable in the sense of there's only one way to change the value. You see down below is the set exclamation point.
Ah, okay.
So all expressions produce new values. For example, this append does not modify the input value. It produces a new list. So the original lists remain intact. There's a kind of semi-immutability. It's just like if they got rid of this set bang, you would have no mutability. It would be like Erlang. And I like that they use the exclamation point at least. They're just like, you are mutating. You better know what the hell you're doing.
Okay.
And you don't use, there's no equal sign. Equal is comparative, is only for comparison. To make a point, I never define any functions in here. Every use of parentheses is the application of existing functions or special forms. So do is a special form. It's a loop. It's not a recursive function or a recursive lambda. It's a loop.
Left paren do space, left paren right paren space, left paren count, right paren. Just tell me what that's doing.
This is going to loop while count is not false.
It's going to do it while count is true or not false, rather.
Sorry, it's going to do it. I'm looking at the code here. I'm having a hard time. Sorry, it's do until count is not false.
Because I think you wrote it a little while ago.
I wrote it a while ago, yeah. And I've been jumping through other languages. So I'm getting confused about the do's versus everything. I'm probably going to edit this part out.
Maybe this is where we should tell the audience, we are not experts in anything we're talking to you about.
Well, I'll just cleverly.
We are new to all this.
I'm going to cleverly edit, jump ahead and say, this is exactly what it does, as if I know exactly what I'm saying. Control operations.
Can you get rid of the shell so we can see more of the code?
This is a do until.
Do until count.
Do until
is not false.
Right. It's awkward syntax. I don't really care for the syntax too much, but that's what it is.
Right? Okay, so what about the next statement? Is this left paren if the input is the empty string or is not the empty string? What is the equals question mark?
Yeah, so the line after the do is left paren if space left paren string equals question mark all together space input space double quote right paren. If input is empty string.
And then you're going to say begin. And that's an interesting statement, actually, begin.
So the begin is necessary when you want to do a sequence of expressions one after the other, not one nested inside the other, but one after the other. in place of where only one expression would otherwise be evaluated. So the if says, give us a condition to test, and then you can follow it with two expressions. One is the true case, and the second expression is optional, is the else case. You don't have to have the else. So here we just have one expression, but in this one expression, I need to define a block. So this would be your, in other languages, would just simply be your open curly brace, your closed curly brace. Here's a bunch of things I want to do. In this case, I want to do two things. I need the begin. The requirement for if is that it's followed by, it doesn't have to be a parenthesized expression. I could just put in there pound T.
Pound T, right.
Right, instead. But obviously...
Which would, by the way, always execute.
Yeah, or pound F, which is never, right?
Which means it would never execute.
But in order to get a expression that turns into a Boolean, I need to have an evaluatable expression. This expression calls this function, and by the way, functions can have names with like they can be, it doesn't have to be just alphanumeric. You can have an equal sign and a...
Are you saying that string equals question mark is all a function name?
It's a function name. It's a specific function.
Oh.
String equals question mark is string comparison.
Okay.
And it's not a requirement, but it's a nice convention that is followed to use question mark at the end of functions that are predicates, right? That return a true or false value. So we've got two things we want to do. We want to display countdown. And then here you can see this is where we're mutating input. I could probably rewrite this in a way in which there was no mutation. Probably would have been a nice exercise, but I didn't take the time to do it. I don't like having mutation, obviously. And I don't like having this, variable showing up 4 or 5 times, however many times that happens in here, but...
Well, you probably would have had to do it more functionally then.
Yeah, this is fairly imperative here. So we've got set bang input. We do a get line. I mean, a get line is very side effectful anyway. We're going out to the user. We're getting whatever its input. Get line is a standard library function. We have to specify the input port. We just say current input port corresponds to standard in. Again, we're evaluating this. We're applying this first. Then we assign it to input, and then we move on to the next line.
Getting back to that point about the being more functional, you remember when we did the F sharp, and I was talking about the fact that in F sharp, I could have written a version that was more imperative because F sharp gives you that option where Erlang doesn't. I couldn't have written it more imperative in Erlang, but I could in F sharp. You've got that option here. In this case, with the set back.
Yeah, I'm kind of feeling bad, like I should have written one in a more functional style.
It's like we're developing a religion. No, mutability.
Well, there's reasons not to do it, though. I mean, it's a landmine. It's not
I like it better.
It's not we do functional programming because it's a religion we believe in. It's like we do it because it provides these values about programming that are highly beneficial. I mean, that's why I'm doing it.
And mutability is safer.
And I don't care if you call it FP or call it something else. As long as I get that benefit, I'm going to do that thing, right? So avoiding shared mutable state is the devil. I think we can all agree on that.
I'm certainly getting to the point where I agree to it. It's actually kind of funny since we started doing this and having these discussions and then having started to work in these things and then going back and looking at the C code and going, oh, wow, this, I'm really starting to come to the understanding because you're right. There is a lot of terrible things about shared state.
Well, it's funny. It's funny that I don't know if you've seen the 4 quadrants of mutation, right? Share and mutation. So share or don't share, it doesn't matter. If you don't share it, you can mutate it, not mutate it. Those 2 quadrants are fine. If you share it, as long as it's not mutated, you're fine. The only one you have trouble with is if you share it, it's mutated. Well, it should be only 1 out of 4 times I'm in trouble, but it turns out when we write code, we're spending most of our time writing our code in this box.
Yeah.
And very little in the other 3 boxes.
Shared mutable state, yeah.
And that's the box that matters. That's the devil. Okay. So left paren, set, bang, space, count, we call string to number. Right. If it fails...
And again, that's a whole function name. String dash right angle bracket number is a whole function.
Yeah.
That's really interesting. That I didn't realize that when I was first looking at it, that those are not syntax. Those are actually names of the function.
That's right. It is kind of a standard you'll see a lot. Conversions have that. dash greater than, little pointer arrow, string to number, number to string, that sort of thing. So again, we got an if, and we've got this compound nested expression.
You're checking for whether or not count is not an integer. And that's what the or is. You're saying if count is not an integer, or it's an integer, it's less than 0.
Yeah.
I can't remember what it's called when you don't, if the first part satisfies the condition, then you don't do the second part at all. So you don't get an error. You find that in C with Boolean. Short circuiting. So you find that in C where you can do an if statement, like check to see if something is null first. You say, if this is, it's like you do an or condition on if this is null or if it's less than 0. That means if it is null, it's not going to check for less than 0. It's not going to check to see if it's a number, which would cause an error. And that only works because you're short circuiting. For example, you can't do that in SQL. Is an example of where they don't do short circuiting. So you're going to do both sides of the if condition regardless, which means you have to satisfy both without error. So in this case, you've got what looks like something similar. You've got an or condition, but it's going to short circuit so that if it's not an integer, then it's going to satisfy the or. If it is an integer, then you can safely do is count less than 0.
Yeah, that's a good point. Actually, there are some languages in which they use two different I think, is it Erlang? Isn't there like or else? Yeah, that's what it is. It's like and also.
I haven't seen
and
that.
Also is the short circuit one, and the just and is not short circuiting. It actually will evaluate both, and then you have to say and also. If it fails the first one, it won't evaluate the second one. If you say and,
it's interesting that they found a usability for having both options. One that short circuits and one that doesn't.
Yeah. It's a form of lazy evaluation. It's not.
I'm curious.
It's not evaluate something if you don't need to. And Haskell is a language in which every calculation is lazy, meaning which is interesting. It changes
short circuits everything.
It short circuits everything, and you have to actually write your code with this awareness. It changes the way you think about the programming. It's one of the things about Haskell that's quite remarkable. There are very few languages that are lazy evaluated like that. The opposite is what's called strict evaluation. Most things are strictly evaluated.
We haven't looked at Haskell yet.
Yeah, somebody submitted a Bye Bye Hello World in Haskell. I haven't looked at it, but it ran.
Well, we should get in touch with him and see if we should get in touch with him, see if he wants to do a bbhw and tell us about it.
If he, she, they're open to it.
Yeah.
But the point I was making is, do you notice anything unusual about the or, the if or not, and the less than? In particular, how would you write it in other languages most of the time?
The not is, again, another function. It's another, what did you call it? Special case or something? Well, it's not a special case. The or, this
special
what
form.
You call it? A special case? Special form. Or is a special form. Not is not a special form. So I'm guessing less than is a function and not a special form. Well, okay, let's try this. You appear to be looking for a particular answer. So am I not getting what you're pointing to?
I'm going to write this the way it would normally be written in other languages.
All right. Well, yes. Okay, right. I get what you're saying.
So
there.
For audience listeners, I took the sub-expression, which was less than sign, space count, space 0, and in parentheses, and instead I put count, space, less than 0.
Well, you wrote it now you've written it imperatively.
This could still be a declarative thing. The way we normally use comparisons and arithmetic operators, like plus, minus, it's called infix. This is infixed, in which the operator is between the two operands, right? Your left operand, operator, right operand, it's called infix operation. But Scheme and Lisp does not support infix operations because everything is function application. So the operation is always expressed as a prefix. So you're reading it as, I'm going to do a less than comparison. The next argument's going to be the left part of that. The next argument, the second argument's going to be the right part of that. We look at it, it feels very unnatural to us, right? Coming from the world of arithmetic and other programming.
But that's the point when you said, does something look strange to you?
Yeah.
Because we've been sitting here talking about list processing,
yeah,
and we're going through this. I'm looking at it going, no, That makes perfect sense to me. It's a less than operation. The first one is the left-hand side. The second one is the right-hand side.
If you look at the whole expression, it's weird, right? If or not.
Yeah.
If I said that to someone in any other language, they'd be like, what the hell did you just say?
If you just wrote down less than count 0 on a blackboard and said, what does that mean?
And you're right. If I take out the parentheses, right, it's unreadable.
Yeah.
It's like, it's the way I just said it is what it sounds like. If or not integer count, less than what?
Yeah, exactly.
But the point you made is the parens are critical here in giving us the Russian doll structure. And we know we're just going to go into that lowest doll first. In this case, less than count 0 and is count an integer. Then the results of those get passed to the not doll. And then the result of that gets passed to the or doll, and the result of that gets passed upward to the if doll, which is the outermost doll. So you're very comfortable reading this. It's interesting.
Yeah.
I am too.
I'm comfortable with that because I've worked with a lot of different languages that do different orders of operations. I mean, I've worked with stack-based languages, like in a programmable calculator, and that's all stack-based. So that writing in PDF, PostScript, those are all stack-based. What we used to call reverse Polish notation. You put the values in first.
Oh, because it's
like if you want to add something,
you
put in like 1, then add. I'm not sure it's PC to call it either reverse Polish or forward Polish.
And it's not an insult. Polish is cool.
Hey, I'm married to a Polish woman, so I know she.
Yeah, anybody from Poland is Polish. I mean, let's call it Portuguese. That's fine. Portuguese,
exactly.
Reverse Portuguese notation. So the rest of it's pretty straightforward. If or not integer count. Listen, basically, if we get the number we want, and you can see I don't have to do a lot of work to validate it here. I test for integer. That's a standard library function. And then if it is an integer, I check to see if it's less than 0. I don't have to do anything else. I actually had to do more work in the other languages to make sure that, we didn't have the floating point numbers and lists of numbers and stuff. So that worked out pretty well. Then we do the begin. We do an open. We got another block. We're going to do 3 things here. We're going to display say we got the invalid countdown. Then we're going to assign false back to count so that our loop continues, because we did convert our number, right? And it might not be false anymore. It could be just something that's not valid. So this is a case in which we are mutating a variable and we are changing its type. We're starting it with a Boolean false value. Then we're giving it a possible numeric value.
Well, it's dynamic typing.
Okay, so we display invalid countdown. We've got some string interpolation here. That's what the format method provides. It's your typical kind of sprintf, right? So begin, display, format it, put the input inside there.
The tilde s, is that the format for string? Erlang has the tilde p, which says print as appropriate for the type.
Yeah, s means string and a is kind of like any. A means printed as the type that it is.
If you said tilde a, then the -1 would probably show up without double quotes.
It might. Let's actually try it and see what happens. I'm going to type in run -1. Yeah, see?
Hey! Now put in frog.
I think it won't put it in quotes. Let's see what happens. Yeah.
Oh, wow. It didn't.
All right, we set the count to false, so we've set bang. We got that 3 times in here. Set count to false. Keeps us in our
irritates you
loop.
more and more every time you see it.
We set our input back to empty string so that we get the prompt again back at the top.
Your final parenthesis out there, you go down to the last parenthesis on your next line. There you go. And that's back up at the do.
Yeah.
And that's something that people who are not familiar with Lisp are going to be looking at the do going, well, where's my end?
This is a convention that Lispers follow, which I like. I actually do this in non-Lisp languages, and I'm sure people hate me for it. If we were in a non-Lisp language, somebody would say, well, the close paren needs to be vertically aligned, right? Which means this one would have to be vertically aligned here. And this one would have to, if people can't see what we're doing, what I'm doing, instead of having the final parentheses, in Lisp, when you have a block of parentheses, they're all on that last line at the end of the line. I'm doing what you see in block languages where your braces match up. You've got a new line with the brace lining up.
Right. you're doing the K&R style of bracing with parentheses. Of course, I like the Whitesmith style of bracing in those type of languages. But if Lisp was different than the way this is, because every expression is surrounded by parentheses.
Yeah.
That's very simple and very straightforward.
I,
If, on the other hand, it had it like it does in C, where you've got the command like the if statement, then followed by an open parenthesis, then I would be very irritated with having all the parentheses
I'm wondering if I have a bias towards scheme because it is a standard practice to put all those closing things. And so the code can be a lot more condensed, my style. I just cannot stand gratuitous blank lines. I can't tell you the number of times.
I know you do. We've had this talk. I don't have a problem with blank lines.
I'm looking at code all the time, whether it's in
Yep.
Kotlin, Java, Swift, C++, C, Rust. And I come across people with code and they'll put like 3 blank lines there, you know, to make their that.
Well, I don't
yeah. They'll do that.
I don't like 3 blank lines.
What is this? How is this helping?
I know,
me?
but again, that kind of thing is just a difference.
Look at how much more scrolling I now have to do thanks to your
I know
blank
that's
lines.
the thing. That's the thing that bothers you. I don't mind the scrolling. We've had that argument before.
Well, look at how
I
great
don't
it is for the
scrolling.
video. I mean, with the shell, we can almost get the
Well,
whole
yeah,
thing
no,
there.
yes, and if we were, and you know,
In
going
APL,
back to
we
the
can see the
days
whole
of,
thing in 3 lines.
I mean, going back to the days of working on the 5110, I mean, that was a real big problem. I mean, you could only see 14 lines at a time, you know, but that's not where we are now. For me, it's easy enough to
you know
scroll
what? People
backward
make
and
that
forward.
argument about 80 columns. They're like, I like 128. Well, yeah, but now then you can't have 4 windows on the screen. See,
That's very true.
Notice when
I
I do
tend
my
to keep
source,
things down.
I like having a bunch of little windows, and that's why I want all the source to be readable
Right.
within those things. Let's see, did I make 80 here? 78. I always wrap at 80.
So you're
Anyway,
within it.
I like that you're liking this style. So that's the loop. We get down. The rest is pretty straightforward. Display, world, hello, flush the output port. Notice we have flushes here, and we do need
I am
them.
curious. I'm curious about that.
We do have flushes.
So on our display line,
Yeah.
you're telling it to display the output world hello, but then you're immediately following that with another expression. There is no restriction here by me saying left paren display world hello, right paren. You can put it all on one line if you want to.
Yes, the new lines are not significant. They're
They're
white space.
irrelevant.
Even though it goes against the grain a little bit, I think people would say put it on
No,
a separate line.
the truth of the matter is I kind of like it that way.
Well, I like it because it matches what we see. It's kind of
exactly.
like
It's
you're
relatable.
doing it, you're flushing
You're
it.
saying the display and then flushing the output. It's almost one statement, really.
Notice the indentation. I'm following
Mm-hmm.
a kind of convention that most Lisp programmers follow. I don't have to indent like this, right? I could indent any way I want.
You're lining up on the parentheses, kind of.
Well, you line up on the significant parts of the expression that are equivalent. So, for example, on the if here, right? Because if I were to do like, okay, I'm going to do 4 spaces on every indent or 2 spaces on every indent, but in this case, I'm lining up where the different parts of the expression are. And you're right. I don't really do this in other languages. I'm doing it here, but it's pretty much a standard for Lisp. Definitely some strong beliefs about using formatters.
Well, I would say that belief comes from wanting all the code to look exactly the same so that a programmer that comes behind you can understand it. But I write my code pretty damn legible and pretty damn readable. And if the guy that comes behind you can't read it...
I actually like people writing code in different ways because then I know who wrote the code. And if I'm working on a small team, I want to be able to know, oh yeah, I recognize this style. I know who wrote that.
But
the way
you're
should
writing
be
this here,
interchangeable parts. I think we should be unique individuals. Sorry, I go against the grain on that one.
Well, and how do we learn from each other if we're all going to a standard set by some?
Sometimes if you follow the rules, it doesn't look good.
That's the
I've actually
point.
started to do the thing you were doing. I'm now doing in Swift code now. I'm doing my variable declarations where I line up all the values. I columnize.
On the equals?
I columnize. No, I'm columnizing. I used to do that a long time ago, and I stopped doing it because the standard practice in the industry was to never do that.
To do it.
And now I look at standard code and I find it hard to read. It's like my eyes are trying to make it. You've got like 5 variables, and just because the names of the variables happen to be different lengths, it's like this one's equal to 1 and that one's 2 and this one's 3 here and that one's 4. It's like, just line the damn thing up. Why do you think people like looking at spreadsheets? It's linear.
Exactly.
It lines up. It's readable.
Well,
Tables are always easier to read than randomly arranged things.
Well, not only that, but tabulation has been around
Yeah.
since way before
I'm into
computers.
it. All right, so we got our loop. We got another loop here. This one's a for loop. The difference was the do there. It was do until, right? So there was there's no counter. It just would just keep looping until the count was non-false, right? That's why the do above has nothing in the first argument parentheses. This is now a for loop. Here's our actual for counter in there. This is just a variable definition. Take count, assign to I on each subsequent iteration, apply this operation, which was subtract 1 from I.
What you're saying is the first element of the do is the iterator, if any, and the second element is the until.
Yes.
You have extra parentheses around
Yeah.
the arguments. Is that necessary?
Yeah, I don't like it.
I'm curious as to why it was necessary.
Because you can do this.
Should we describe it for the audio people?
Yeah. The first set of parentheses defines within do a let block. It's a set of scoped declarations. The lexical scope for variables is a little odd in Scheme. Let's just put it that way. This thing you're saying is an iterator. It's a more generic way of saying you can update some values here over the cycle of the iteration. I don't care what they are. I don't care what you do, but I'll just update them for you. Notice that the test condition is completely independent of that.
Right, that's the until condition. I can see that.
But I didn't have to use I here.
They're completely independent. No, I get that.
Yeah, they're completely independent. All I'm doing is I'm testing for I, but before I test for I, this is the calculation that I'm making for I on each iteration. The do block works by saying you can assign a bunch of variables and define an operation to be updating them on each cycle. I don't care why you're doing it, but that's what I'm going to do for you. By the way, also, here's a condition you can test for to determine whether we should stop iterating. You can use this generic facility to create a standard for loop, rather than a for loop has only got this iterative thing and it's only testing for that. It's like you're just generalizing the mechanisms that you would need for a for loop.
The point is that the variable I is available in the other scope.
It's available throughout the entire do.
It's available throughout the. Okay. Could you do anything else in the iterator block of the do?
No. Normally, any set of parentheses, the first thing you do is function application, but the rules change. That's why this is a special form, because if this was a function, this next thing would have to be an argument to that function.
Right.
But it's a special form saying the next element in my list, the first element is do. The next element in my list is the clause of declaring variables. The third element in my list is the clause for the condition test.
The until, is that the same thing? I could have multiple conditions there or something?
The outer parentheses defines the clause. The inner parentheses defines function application.
So you couldn't have multiple of those?
No.
In that clause.
Well, I'd have to use something that combines, like I'd have to say or.
Yeah, in other words, a normal combination.
That's why the special forms have a particular structure to them. Now, the one thing I haven't gotten into in Lisps and schemes, you could easily create your own special forms with special rules just by defining macros. The macro system is very flexible in here. Just the fact that everything ultimately boils down to expressions within expressions within expressions, that's a whole nother can of worms.
Yes, I can see that.
Two things that I'm not doing in this example that are the superpowers of Lisp. Three things. One is I'm not defining any functions. I'm using existing functions and special forms. I'm not using any macros. I'm not expressing data as code. I'm not building up code as a block of data and then passing it to be evaluated. I could do that in here.
Okay.
It can eat itself. It can like eat its own dog food kind of sort of thing. Anyway. All right.
Inside the do, we've got a begin. And that is because we are going to do, just because we're going to do more than one thing, right?
Yeah, and I didn't have to do that up above. Why do I have to do the begin here?
Maybe you didn't need to begin.
Maybe I don't need to begin.
Let's find out.
Yeah, that's probably redundant. But there's an extra. Yeah,
you're going to have to take.
There we go.
There you should be good now.
All right, let's try that.
I think.
Yeah, it's run 4. There we go. You're right. Okay.
Voila.
You're better at Scheme than I am already.
So let's take a look
Some
at what it's doing.
special forms will allow you to have a sequence of expressions. The if doesn't. because if I put two expressions, it would have treated the second one as the false condition.
Sure.
So I'm like, no, no, no. I want all these things to be part of that single first expression. So I got to make a begin block to do that. What's interesting about Lisp that I'm finding as we're discussing it, the syntax is simple and yet it's so flexible. We're using do to do a while until, a not while until, a for loop, a whatever, because it provides the basic iterative mechanisms and update cycle if you want it and whatever, so that you could construct bespoke variations on iterators. What's also interesting, how different of a language this is in so many ways from the array languages. And yet, to me, there's a similar quality of elegance. It's completely different than thinking about programming in APL. APL, the parsing order, the semantics, the symbols, the idea of function application, all that, it all works very differently. And yet, there's an elegance in the way that it thinks, and there's an elegance in the way that this thinks.
So looking at the display, so we figured out we're inside the do.
We're inside
and
the
you
do.
have your display, and you're formatting. So that your next expression is you're going to format that expression
using the keyword format. Yeah.
And then you're going to display that and then flush the output port. So that's very much the same as the previous display. The sleep.
Yeah.
Is that a function or is it a special
function.
form?
No, it's a function.
It didn't come up in purple here, so that's why I was curious.
Yeah, neither did format. So this syntax highlighter is not made for chez scheme. It's made for general schemes. So it's not sure what's in this library or not.
Make time is obviously a function. That's not being highlighted either.
Yeah.
What's the single quote mean?
Single quote is actually in scheme called quote.
Okay.
It turns whatever you've got into a literal. That is how
So it's like an atom.
It is an atom. That's how you do atoms.
So make time takes a parameter to say what kind of time you're making?
Yeah.
Okay. And you pass in time duration. Now, could you pass that in as in double quotes, the whole string, or is it just as an atom? In other words,
it won't like it if it's a string. It expects an atom.
Curious.
It's an atom like in Erlang. A literal string is not a literal atom. They're not the same thing.
Right.
All right. So that's it. We see display by.
The way this is written, and I'm going to say that unless you remove the mutability, which you can do with the set bang, you're actually going to get more code out of it to write this functionally. Am I right about that?
I think their do's could be done using recursive lambdas, and that would get rid of the mutable variables. But I haven't done that here. So that's the other thing. There's no lambdas in here. There's no anonymous functions because I don't define any functions. These are all applications of either special forms or existing functions. You can define lambdas in here just like you can anywhere else. And you can call them recursively. So I'm not doing any of that. So we're not really showing a lot of the unique functionalizations of a scheme in Lisp. Let's look at the other implementations and see how much different they are. So this is chez. Now we're going to look at chibi. So chibi's one of the little light embeddable guys. Now chez is a big implementation. There's a big library, a big thing there. It would be hard to embed it. I think it's pretty much written in C. That's why we can build it easily. But it's big. And chibi is small.
I see you're bringing in a couple of things with this import command.
So for people who are listening, the chibi code looks very much the same. The big difference is at the very beginning, we have an import statement before we define count and do all the other things. So we've got a left paren, import space, left paren, scheme space, small, right paren, left paren, srfi space 18, close paren. We're importing something called scheme small, something called srfi 18. What the hell is srfi 18? I've got comments at the end of each of those imports telling you why they're needed.
Well, I am curious because the first one says required for command line, which I understand.
Yeah.
Define and display. Does that mean that define is not special form for scheme? It's a special form for chez scheme?
Chibi's R7, so it's newer. It's on the latest standard. And chez is still on R6. One of the arguments against R6 was that it was too big. people said they put a lot of stuff in there and they didn't like it. So what they decided to do in R7 is break it into two pieces, what they call small, which is like the minimal subset of stuff you need, and then large. So far, they've only standardized the small part.
Chibi by itself does not include the define.
Well, I think this is a case in which chibi, a lot of the chibi code is written in Scheme itself. So the C code is a very small footprint, and then all the additional stuff you need beyond that is written in Scheme. And in order to make it available, it's written as a Scheme library. I think this is unique for chibi. As if we go to the other ones, we'll see we don't need the same imports. So we'll come back to that. This one is Gambit. Most of the code is the same, but a few differences. We don't need the imports in chez. In other words, everything we needed, command line, define, display, they're just built in. They're just part of the R6 standard. They're built in by default. No importing is required. Chibi is a very small thing, and so they basically said, well, we want to give you all the R7 stuff, but we don't want to make that part of the core, so if you don't need it, you don't have to include it. So we can have a small footprint. But we're going to give you most of the stuff you want to use in the form of Scheme libraries.
Does that mean that you cannot define variables imperatively in chibi?
No, it means I can't do it without doing the import. I just need the import.
So is there another way to create variables?
I don't know. I don't think so.
What could you write in chibi without importing anything?
Oh, you could,
where you couldn't define variables.
Just expressions that evaluate literals and call existing functions.
Okay. So that's all you could do is create functions.
Well, you're asking me more than I know. This is what I needed to do to implement bye hello world. But I want to make the point about srfis.
Scheme requests for implementation.
So we have the standards. The standards say, here's how the language works. Here's the special forms. Here's the standard library. If you want to do anything beyond that, we have this thing called requests for implementations, and we're going to number them. These are expansions to the language that implementers can optionally implement, and they tell you whether they implement them or not. So when you jump from Scheme implementation to Scheme implementation, they'll say, we support srfi 18, or we support srfi 32, or we support srfi 33. It's a way of standardizing everything we talked about, whereas like in JavaScript and other languages, they just decide to pile stuff on, or people make random libraries. This is a way of saying, here's a bunch of standard features or libraries that we can all agree upon, but we don't have to have them in every implementation of the language. In fact, the implementations can just opt in or not that they support that. So if somebody says they support R7, you go, okay, I can count on R7 being there. But if I want any of these other things, I got to go to the implementation and see if it has it. And if it doesn't, maybe I'll add my own. And there's a lot.
Yeah, I can see that. So you pulled in 18. What does 18 have in it? There it is.
Multi-threading support.
Multi-threading support. Okay.
This is thread sleep.
Yeah.
So we noticed that in chez scheme, they have a built-in sleep.
Yeah.
That's one of the things that happens in R7. They say we're going to keep the language small and put a lot of the other stuff as srfis or part of large or something like that. And these guys go, okay, well, here's it. Now, if you support 18, you have to follow the spec the way it says you have to follow it, right? So let's take a look at that. Let's go to the document itself. Here it is. It says, here we go. Thread, mutex, condition variable, time, rationale, specification. Right? This is a whole design here.
Wow.
Thread sleep. I was able to do everything that I needed to do, right? Even in J, I didn't have the flush. Even chibi, as small and lightweight as it is, has everything I needed for bye hello world. This completely works. Just as good as the chez one works. I just had to code it a little bit differently. That's what srfis are. And there's a lot of stuff in there. A lot of stuff. Immutable strings. Integer division. All kinds of stuff. You can see schemes get used. It's out there. It may not be mainstream, but it is out in the world and it is being used. And there's a lot of people that work with it. So back to the code.
Everything is the same except your begin display. You've got a string append as opposed to the format.
Looks pretty
There's
much
really,
the same,
you're right,
similar.
very little difference. The basic scheme stuff is still there.
Yeah. So now let's go on to Gambit. Gambit scheme is next. All right, that's pretty close.
All right, you're bringing srfi 48. Can we take a look at srfi 48?
Well, I say right there, required for format.
I know it's required for format. I was
Oh,
just
I
curious.
remember.
See what
That's
else is in it.
why I didn't have it in chibi. Because they don't have srfi 48. I looked for it.
For
Wasn't
chibi.
there? Remember, srfis are optional. Each implementation decides whether they're going to support it or not.
Gambit does support command line.
Yeah, it has command line built
supports
in.
command line.
Yeah.
So it looks like it intrinsically has 18 in there because it's got thread sleep.
Yeah.
So this is almost exactly the same as chez, and the thread sleep is different. So it's because chez has sleep intrinsically.
And remember, chez is R6. So Gambit is R5 and R7. So Gambit skipped over R6.
Got it.
There's a lot of controversy around R6. People felt like there was an abomination or something. And so R7 comes along. It's like, we're kind of back to the roots of R5.
I noticed something else. You have a shebang at the top, and you said that that is required to receive command line arguments.
Ah, you picked up on that. Yeah. This was unique to Gambit. Without that, I don't get the arguments, or it's blank, something like that. Yeah.
Curious.
So another scheme, S7.
S7. This is the other one I wanted to look at.
So this is the one that I embedded inside Unreal Engine. I'm using this as a way to script Unreal Engine. Now I've modified it because I've based my own language on Scheme by changing some of the syntax first, and now I'm going in a new direction. But I'm still using the kind of just slightly syntax altered version of Scheme. But notice a couple of weaknesses here in the S7. Boom.
The REPL doesn't support command line args at all.
The S7 REPL is pretty minimal. It's almost nothing. It's not meant to be used as a REPL. It's meant to be used as a scripting tool. So I don't get command line args at all.
Can we run this one?
Let's switch to shell. S7, do a run. I put the comment out just in case.
Okay.
Do 2. Does not support sleep.
There's no sleep. Yeah, okay.
Yeah.
Curious.
So if I say run 15, it doesn't matter. And if I say 99.
Well, you can't take command line parameters at all, so.
Yeah. So it lacks sleep, and it lacks 2 gaps on S7.
I'm seeing some other things too. You say that this is all based on R7 though. S7 is based on R7?
It is.
And to set input, you've got a let statement. We haven't seen that before. So is that R7? Is that something new?
Let has been around forever. So let is a variable declaration that's scoped.
Okay.
So the defines,
They're global.
they are global.
So what we're doing is letting S, and I notice here we're using the extra parentheses again. So is that a clause again?
Yeah, let is this. The block inside the do is the same structure as let clauses. Let is basically the keyword that says define a block of variables. Do does that without the let. The let's implied, right? So it's like, here's your block of variables for the do. This is just, here's your block of variables for whatever. The lexical scope starts here and ends there. S does not exist outside of that let scope. It defines a scope for variables. As soon as we leave my scope, those variables are gone.
The first clause in the let is letting you define a set of lexical values.
Right, exactly.
And then the second clause,
I could do a bunch of them in here. And then these just live for the duration of that let expression.
but this is the actual evaluation that is going to be returned to input.
It's like the do, the begin isn't required. You can have multiple expressions.
Oh, you can?
The begin is implied. Yeah, you can have as many as you want till the close paren. And then the value returned is whatever the last expression was.
Okay. Looks like you're saying you're doing a set to input.
Keep in mind our audio listeners have no idea what we're looking at.
Right. So the difference here is we're doing, so we have the do loop at the top again. And then, but our set statement on the input value is a little different.
That's because our read line is a different function. If we look back at the others, it's a different function when we take input from the user. Actually, on Gambit, it's read line. And you can see right there, it just directly says set bang input open paren read line close paren. Whatever the user types in, we're doing a read line. We assign it to input, that's fine. It doesn't work on F7. On F7, when I take the read line
You have to pull off the line feed.
I have to pull off the carriage return, at the end.
Yeah.
So
Yeah, I had to do the same thing in Erlang, you remember?
Yeah. And notice it's kind of awkward. It's like I've got a substring.
Yeah.
There wasn't a nice convenient function of, give me everything but the rightmost character at the end. I literally do the typical C. This is like a typical C code where it's like, find out the length of the string, subtract by 1, do a substring from that to the end of the string. Yeah.
Although there's probably one thing we should mention is the whole thing is surrounded by a begin block.
Yes.
Apparently, is that necessary for S7?
Yes. I'm glad you picked up on that. S7 is not really meant to be executed from files. The scripting is kind of an add-on feature. That's why the REPL is so lightweight. It's meant that you pass strings inside of and that's why I have to put the begin in block, because it says, give me a single expression to evaluate. Okay, here's your single expression. It's all this stuff.
S7, like you said, clearly has a minimalist approach to it.
Chibi is a collection of files. It's a small footprint. S7 is a single .h file and a single .c file. It supports a lot. It's surprising how much is in there, and it's fast. It's one of the reasons I use it inside Unreal Engine. I'm doing like geometric calculations on large numbers of vertices using this thing.
Yeah.
It's pretty fast. It's been around for a while. A lot of guys that use S7 use it inside music programs. Next, here's Racke. We're not going to fully discuss it, but it looks pretty close. But there's some notable differences here.
Yeah.
The key one that we're going to talk about when we deal with Racke is this guy right here.
Language.
Lang Racke.
So you have to tell it that it's Racke.
Yeah, but you can also tell it Lang Steve. And then suddenly the syntax is whatever the hell you want it to be. You can build languages with Racke. That's its superpower. It's language-oriented programming. When we talk about DSLs and other languages, this is the one that takes this idea to its fullest extent. And what's interesting is the Racke implementation, guess what it's built on? Chez scheme. Originally, it was its own, and then the guys who were maintaining the kind of core library or the core functionality of the language were trying to just continue to tune performance, and they're just like, these Chez scheme guys have put so much work into the performance, we'll just use what they did, and they use it as a foundation.
Are we going to talk about Racke, or
No.
are we going to do another episode to talk about
We're doing
Racke?
another episode. Any
right.
final thoughts for you on scheme and lisps in general?
I like about, like I said, the minimalist syntax. The thing I didn't like about it, I wasn't crazy about the double braces for those clauses on those statements. A little disappointed.
The double parens?
Yeah, double parens.
Yeah.
I was a little disappointed there wasn't a better solution to how to handle that, but I understand the problem they were up against because they're trying to stay minimalist. I really did like the fact that you could use a range of symbols. I know you're not crazy about the range of symbols for the function names, but I thought it really allowed you to be much more descriptive, where you could say string, dash, right angle bracket, number. That's clear to me. I read that and say, oh, that's going to convert a string to a number. Simple, very, very descriptive. Of course, you could always do like you could do with a camel case or a Pascal case where you say string to number if you want to do something like that. That's kind of ugly.
It's one of the few languages in which you can use a dash in the names. Underscore lowercase letters is snake case, and with dashes it's kebab case, because it's like a kebab, right, versus a snake.
Clever. I found it very, very easy to understand it. The left to right expression processing with parentheses is a no-brainer for me. That
Russian
one's real
dolls,
easy.
the going in and coming out.
Yeah, that's
Inside out,
standard
inside out.
That's what we all know about operator precedence, right?
True, but
Parentheses always come
you
first.
really feel it in Lisp. You feel it more than anywhere else that you're drilling down into the inner core and then coming back out again.
I'm going to be very interested to take a look at LFE when I get to that. Now that I've had some exposure to Lisp.
We're shining the light on a lot of lesser known, lesser used languages. So Elixir's pretty mainstream now. It's one of the biggies.
No, that's a good point. That's a good point.
LFE, almost nobody knows about LFE. Gleam is taking off like a rocket right now.
Well, I'm going to focus more in the Beam languages for the moment. So
do
I think
Elixir, LFE, then Gleam. How's that sound?
sounds good. All right. Well,
And I don't know what I'm going to do next. Maybe K. I want to get back to the array languages. So one of us is going to have to do Weewa at some point. Do you want to do it? Or
I
do you
would
want
like to. Well, I will certainly
I'll leave that
consider
one for
doing
you.
it.
I'll try to get Stephen Taylor, who is the K librarian from Raycast, before or after I make my attempt at trying to do it in K. So,
Okay.
all right, that's
all
it for
fun.
us. And
Okay.
I wish myself and you and everyone else the best of luck.
Bye, everybody.
Bye bye.